My dear students, in this video I am going to share an important topic which is very important for IIT-JAM, NET, SET and GATE exams. The topic is Beer-Lambert's law and some numerical problems based on this law. First of all, let us discuss about the Beer-Lambert's law.
Now in this diagram you can see that a monochromatic light. Monochromatic means the light having only one particular frequency. So when such a monochromatic light is passed through a solution, then
the intensity of the light decreases.
The Beer-Lambert's law is simply the extension of Lambert's law, and it states that when a monochromatic light is passed through a solution, the
Decrease in intensity I
of the light with thickness x of the solution is not only proportional to the intensity I of the incident light but also to the concentration of the solution. So mathematically we can write minus di by dx is directly proportional to I into C, and minus di by dx is equal to kappa into I into C, where kappa is a proportionality constant and is called molar absorption coefficient. It is constant for a particular spectral transition, and its value is dependent on the nature of the absorbing solute and the wavelength of the light used. So here the minus sign is used simply to indicate that the intensity of the light decreases after absorption. Okay, so now from equation 1 we can write that minus di by I is equal to
kappa into C into dx.
Now on integrating this equation within limits x equal to 0 to x and I equal to I0 to I, we get integration I0 to I di by I equal to minus kappa into C into integration 0 to x dx. So and it gives ln I by I0 within limit I0 to I equal to minus kappa into C into x, from which we can write that ln I by I0 is equal to minus kappa into C into x and give it equation number 2. And then again we can write I by I0 is equal to exponential minus kappa Cx. This implies I equal to I0 into exponential minus kappa Cx, give it equation number 3. Now from equation 2 we can get 2.303 log of I0 by I equal to minus kappa Cx, and this implies log of I by I0 is equal to minus kappa by 2.303 into Cx, and this implies I log of I0 by I equal to kappa by 2.303 into Cx, just reversing the quantity within bracket of logarithmic term. Then this implies log of I0 by I equal to epsilon Cx, give it equation number 4, where this epsilon equal to kappa by 2.303, and it is known as the molar extinction coefficient or molar absorption coefficient, or it is also known as decadic extinction coefficient, where deca means base 10. So from this equation we can write A equal to epsilon Cx, give it equation number 5, where A is equal to log of I0 by I, and it is called the absorbance or optical density of the substance. Now let us define what is molar extinction coefficient. So we have log of I0 by I equal to epsilon Cx, from which we can write epsilon equal to 1 by Cx into log of I0 by I. Now if we write C equal to 1 molar and log of I0 by I equal to 1, then epsilon equal to 1 by x. So thus the molar extinction coefficient may be defined as the reciprocal of that thickness of the solution layer of 1 molar concentration, which reduces the intensity of the light to 1 by 10 of the incident light. Okay, and it is a very important parameter, and its value is dependent on the nature of the absorbing material and the wavelength of the light used. Now we'll see a relationship between the absorbance and transmittance. Already we have discussed that A is equal to log of I0 by I is known as absorbance. So similarly I by I0 is called the transmittance, and it is denoted by T. So we can write that percentage transmission percentage T equal to I by I0 into 100. So this implies I by I0 is equal to percentage T divided by 100. and this implies I0 by I equal to 100 by percentage t. Now taking logarithm on both sides, we get log of I0 by I equal to log of 10 to the power 2 divided by percentage t. We can write 100 is equal to 10 to the power 2, that's why. So this implies A is equal to log of 10 to the power 2 minus log of percentage t, and finally we get A is equal to 2 minus log of percentage t. So if we know the percentage transmission, then we can calculate the absorbance A using this relationship. Now, although this Beer-Lambert equation is very useful, but still there are some limitations, which are that firstly the light must be monochromatic. That means the light that is passed through the solution should have only one frequency, okay, which is quite difficult to obtain. Secondly, a dilute solution is used. That means this solution is this equation does not hold good for the concentrated solutions. Thirdly, the wavelength of the light used should be in the range of the absorption of the solution, and fourthly, there should not be any scattering of the light beam. So these are some limitations of the Beer-Lambert's law. Now let us solve the first numerical problem. The question is state the Beer-Lambert's law. The transmittance of an aqueous solution of potassium permanganate at a certain wavelength is 1%, that is 0.01, for a 10 to the power minus 3 molar solution in a 1 centimeter cell. What is the absorbance and the molar absorption coefficient of K, M and O4? So first part we already discussed about Beer-Lambert's law. We are going to solve the second part. So let us see how to solve it. We know that T is equal to I by I0, and it is given 0.01. So inverting this equation, we can write I0 by I is equal to 1 by 0.01, which is equal to 100. Now taking logarithm on both sides, we get log of I0 by I is equal to log of 10 square, and log of I0 by I, it is given by A. So this implies we can write A is equal to 2 log of 10, which gives you the value of A equal to 2. That means absorbance is equal to 2. Now again we know that A is equal to epsilon into C into X. So from which we can write epsilon is equal to A by Cx. Substituting the value of A, C and X, we get epsilon equal to 2 divided by 10 to the power minus 3 mole per liter into 1 centimeter, which gives you 2 into 10 to the power 3 liter mole inverse centimeters. Then if we convert centimeter into meter inverse, then we will get 2 into 10 to the power 5 liter per mole per meter, which is the value of the molar extinction coefficient, right? Now here is another problem which was set in CSIR UGC NET examination. The problem is, on passing monochromatic light through a 0.04 molar solution in a cell of 1 centimeter path length, the intensity of the transmitted light was reduced to 50%. Calculate the molar extinction coefficient of the solute in the solution, given the value of log 2 equal to 0.301, and the options are 0.75 liter mole inverse per centimeter inverse, 75 liter mole inverse centimeter inverse, 750 liter mole inverse centimeter inverse, and 7.5 liter mole inverse centimeter inverse. Now let us solve this problem. So here we will use the relationship A is equal to 2 minus log of percentage T, and substituting the value of percentage T, we get A is equal to 2 minus log of 50, since the transmittance value is 50%. So therefore A is equal to 2 minus log of 50, we can write it is 100 by 2, and which will become A is equal to 2 minus log of 10 square minus log 2. So this implies A is equal to 2 minus 2 log 10 plus 0.301. Okay, and A is equal to 2 minus within bracket 2 minus 0.301, and simplifying it, we will get the value of A is equal to 0.301. Now again we know A is equal to epsilon Cx, so substituting the value of A, C and X in this equation, we get 0.301 equal to epsilon into 0.04, which is the value of the concentration, into 1, from which we get epsilon is equal to 0.301 divided by 0.04, and on simplifying it we get epsilon is equal to 7.525 liter mole inverse centimeter inverse. So therefore the option D is the right answer. Next we have another similar type of problem which was also asked in CSIR UGC NET examination. The question is, using cuvettes of 0.5 cm path length, a 10 to the power minus 4 molar solution of a chromophore shows 50% transmittance at a certain wavelength. The molar extinction coefficient of the chromophore at this wavelength is given, the options are given, and the value of log 2 is given 0.301. The options are 1500 meter inverse molar inverse centimeter inverse, 3010, 5000 and 6020. So just like the previous one, in this problem also we will use the relationship A is equal to 2 minus log of percentage T to determine the value of the absorbance A. And since the value is value of percentage transmittance is 50%, so we can calculate A is equal to 0.301. Okay, so again using the relation epsilon A equal to absorbance A is equal to epsilon Cx, substituting the value of A, concentration and the path length x, we get 0.301 is equal to epsilon into 10 to the power minus 4 into 0.5. This implies epsilon is equal to 0.301 divided by 0.5 into 10 to the power minus 4. This implies epsilon is equal to 0.301 divided by 0.5 into 10 to the power 4, and it is equal to 0.602 into 10 to the power 4 molar inverse centimeter inverse. And on simplifying it we get epsilon is equal to 6020 molar inverse centimeter inverse. So that means the option D is the right answer.
Now I request all my dear students to solve as many problems as you can from different books of this topic. If you have any doubts in any problem, then put your questions in the comment box. I will try my best to solve your problem. See you in my next lecture. Thank you.